Hi guys, so today we are learning section 10.4, which is about inscribed angles. So there's a couple new vocab words we're going to learn and a few theorems. Hey, let's go. Okay, so first we are going to define an inscribed angle. And so what an inscribed angle is, it's an angle whose vertex is on the circle and also its sides are chords. So as you can see in this picture, the inscribed angle is this angle right here, this red angle. Its vertex is on the circle. Its sides are chords. So in this particular example, the sides are rays. So like this part is a chord. So part of the sides are chords. Okay, with every inscribed angle comes something called an intercepted arc. So an intercepted arc is the arc that's formed by the sides of the angle. So see how like these two sides of this inscribed angle, they hit the circle here and here. Well, that arc in between, that's called an intercepted arc. Okay, it's in the interior of the angle. So there is something called the inscribed angle theorem that has to do with the measures of the inscribed angle and the intercepted arc. And it says that if you have an inscribed angle, it's half the measure of the arc. So if you look at this picture here, this angle DEF is an inscribed angle. This is its intercepted arc. So this angle here would be half the measure of the arc. I wrote an example over here that says if the measure of arc DF is 90 degrees, find the measure of angle DEF. So you would just cut it in half. So it would just be 90 divided by 2. So it would be 45 degrees. So that's the inscribed angle theorem. I did do a couple quick examples down here. So this first one, we are given angle ABC, which is an inscribed angle. And so we need to just double it to get the intercepted arc. So you're going to do 36 times 2, which is 72 degrees. So that's the measure of arc AC. Okay, the next one, we are given an arc again, and now we have to find the angle. And so this is an inscribed angle. So it's going to just be half. So you're just going to do 62 divided by 2. They do obviously get a little bit more difficult in this, but this is just like the basic theorem, like how you apply the theorem. Okay, the next theorem. This next theorem has to do with still inscribed angles. It's when you have two inscribed angles that have the same intercepted arc, that forces them to be congruent. So if they have the same intercepted arc, like let me show you in this picture. So see arc DA here. Let me use a different color. We have two angles that have that as its intercepted arc. We have angle ACD, and then we have angle DBA. Both of those inscribed angles have this same intercepted arc. And so if the measure of those angles is half that arc, then they are forced to be the same. So just throwing something out there, let's say that arc was 100 degrees, then each angle would be 50 and they'd have to be the same. So that's that theorem. Okay, here's an example using that theorem. So we're given a few inscribed angles and some intercepted arcs. So let's focus on number 3 first. It says find angle U. So angle U is here. Notice the intercepted arc for angle U is the same as the intercepted arc for angle V. So that means that V and U are congruent, making angle U 30 degrees. And then for angle T, let me erase this and we'll use a different color. Okay, so for T and W, notice T and W have the same intercepted arc also. See how angle T has UV and angle W also has UV. So that means that T and W are congruent too. So we're just going to set those equal to each other. And then solve. So subtract 4, subtract 2x, you end up getting 5. This is asking for the measure of angle T, so then you would just plug it in. So you're going to have 3 times 5 plus 4. So that's 15, 19. Okay, so that's that theorem. Next, we have another definition. It's called an inscribed polygon. So an inscribed polygon is basically a polygon that has all of its sides. It's all inside the circle. All of its vertices of the polygon are inscribed angles. So if you take a look at this picture here, just to show you an example of an inscribed polygon, polygon ABCD would be an inscribed polygon. All 4 vertices are on the circle and all of the sides are chords. Okay, so some properties of inscribed polygons. The first one says if an inscribed angle intercepts a diameter, or like a semicircle, the angle is a right angle, which makes sense, right? So if I told you that this segment here, BD, was a diameter, and notice, let me switch to red, notice like angle C is an inscribed angle because see how its vertex is on the circle, its sides are chords. So if you think about like how this is 180, this has to be 90 because it's half. So that's how that theorem works. This one is also 90 because it also intercepts that diameter. So that's that property. The next one is if you have a quadrilateral, and this is only with a quadrilateral, so 4-sided shape, that is inscribed in a circle, just like how I said ABCD is. Its opposite angles are supplementary. So these two add to 180 and these two add to 180. So this one and this one are supplementary, and then this one and this one are supplementary. So that's the other property. So we'll use that for some of these examples down here. So this first one, number 5, we want to find x. So notice that we have this triangle. Angle y is an inscribed angle, and notice that its intercepted arc is this semicircle, intercepts this diameter. So if this is 180, then this is 90. So what we can do is we can take x and x plus 12 and just add those and set it equal to 90. So it's going to be 2x plus 12 equals 90. So it's going to be 2x equals 78. Divide by 2 and you get x is 39. Okay, and then to get w, you're just going to plug in 39 plus 12, which is 51. Okay, number 7. This one is an inscribed quadrilateral. So that means that basically angle x, the measure of angle x plus the measure of angle z is going to be 180. Those are supplementary. And then you're going to have w and y. So measure of angle w plus measure of angle y equals 180. So you're just going to add those, set them equal to 180. You guys know how to solve equations, so I'll tell you what the two answers are. For this equation, w plus y, for that one, you end up getting x is 54. And then for the blue one, x and z, you end up getting y is 31. And then you would just plug in to find these. Okay, so opposite angles in an inscribed quadrilateral add to 180. So those are all the properties and theorems that we are going to do for today. Please join our help session at 11:30 if you have questions. All right, have a great day.